Hi, I'm Tom Fenwick-Smith, and this is the Genuine X podcast. We have partnered up with our friends at Ericsson to find out more about their Innovation Awards program. The Ericsson Innovation Awards is an annual global student competition that sets a new challenge every year. This year's theme was Dive Deeper, a call for teams to take inspiration from under the surface of our oceans. We will be speaking to this year's finalists, each of which has an idea that could change the world. Joining me for these conversations is Carrie Mahoney, Genuine X's Head of Strategy.
Today, we talk to Team Adelaide, otherwise known as Adelaide Bio-AUV. Inspired by the Cuttlefish, this group of friends from Adelaide designed a bio-autonomous underwater vehicle with a unique propulsion system. The design would enable otherwise untraversable underwater exploration. The team hoped to create a commercially viable AUV platform that will assist scientists in crucial data gathering from complex reef systems. A perfect fit for the age of IoT devices. We explore their ambition for the future and the device's possible applications on other planets, such as Europa.
Team Adelaide, your name, I think, was slightly changed when I looked at it to the Bio-AUV. Is that what your team name is?
Yeah, so that's what we're going with at the moment. So Bio-AUV being a bio-inspired autonomous underwater vehicle.
Because when I looked at it, I was like, Bio-AUV, it kind of does exactly what it says on the tin there. Like I kind of almost exactly know what your invention is. It's really interesting.
It's an open book.
Yeah.
We're actually the Adelaide Bio-AUV. We're trying to flex the Adelaide just to get...
Represent.
Yeah.
Nice.
Exactly right.
So, should we just go around and you guys can just introduce yourself and exactly, what your roles are in the team, sort of how you came together, and just a little bit of background about each of you would be really great. And if we start with Daniel first.
I'm Daniel, and I do mechanical and aerospace along with Daniel. Just finished my degree, so did my last ever exam a few weeks ago, which is pretty cool, pretty scary as well. But we all met together. I knew Daniel beforehand, and Jeet and Josh knew each other as well. The pairs didn't know each other. We got put together for an honours project. We did a similar project to what we are doing for Ericsson, and we joined together and it worked out perfectly.
Excellent. And then, Josh, what's your skill set?
So I'm a mechanical engineer as well, but also do computer science. So my role has been all the really technical things, making the thing actually do what it needs to do.
Is this a bit of a bone of contention within the team?
Just all the technical things, all the electronics, all the programming. That's my area of expertise, I guess.
And then Jeet?
So I'm studying mechanical engineering and finance.
Mm-hmm.
So
Classic pairing.
It's getting popular now. So
Good.
It's good.
Of course.
The mechanical engineering is a fallback for when finance doesn't work out, obviously.
Yeah,
okay.
yeah. Because finance is where the money's at. But I'm trying to handle like the business side, talk to stakeholders. And so we use the systems engineering approach. So that's just the method of going through the engineering process. Mm-hmm. So I try to look after that.
Okay, great. Yeah. And then Daniel?
Yeah, so I'm also studying mechanical and aerospace engineering. I've also just finished uni, which is amazing. With the project, I did a lot of the mechanical design work, so a lot of the CAD and laying out how everything was going to fit together.
And can you tell us exactly what your invention is?
Yeah, so what we've created is an autonomous underwater vehicle, similar to a small submarine, which is autonomous. But the one we've created is inspired by the Cuttlefish, which is an animal that lives off the coast of Australia where we live. The propulsion system for our AUV uses the same propulsion system as the Cuttlefish. So instead of using a propeller, it has two membranes on the side which propel it.
Because we've got it with us now.
Yeah.
Do you want to just describe what we've got with us at the moment?
Okay, so it's basically a capsule. It's in cylinder-like shape, and it has two wings on the side. It's about 0.8 metres long, or 0.6 metres long, and the body is out of aluminium. So to get it to this point, as it is now, had to be CNC machined from two big blocks of aluminium, and that took the workshop staff over 200 hours. So
Really? Why?
because it just takes so long.
It just takes so long to
Very
do
intricate,
that?
Yes.
Wow.
That's incredible.
I mean, there's a machine that does it, but he has to control the machine and
Yeah.
set it up perfectly. So,
Starting with the Cuttlefish and just a little bit of background for everybody listening is the theme of this year's Ericsson Innovation Awards is centered around dive deeper. And it's all about trying to harness technology found in nature, something we've been doing for centuries, really, and using that as an inspiration. But in all honesty, did you guys kind of think about the problem first of what you were trying to solve, or were you looking at the Cuttlefish and you're like, wow, that thing moves really interesting? And I mean, no wrong answer here.
So our project title was Design and Build a Bio-inspired Autonomous Underwater Vehicle. So
At university.
At university. So that's what we started with. But we had to find a problem to solve and then kind of develop our solution based on that problem.
So what this competition has really motivated us to do is take this purely research propulsion system and develop it into a commercially successful product. So which is what we've done, which is how we've created it into a platform. So it's like building a rocket ship, and every satellite does something completely different. This allows them to get up there and do what they have to do.
What's the problem that you guys kind of discovered when you were coming towards this, and thought Cuttlefish?
We identified that current and conventional submarines are really difficult to maneuver in tight environments, so deep sea corals, seaweed forests, underwater maintenance tunnels. So there was definitely a gap in something that can access those areas automatically. So that's why we looked at Bio-inspiration, design something that's really maneuverable, so you can control it in those tight environments to access data in those areas.
There's also quite a lot of applications where they use divers instead of autonomous underwater vehicles at the moment, and it's actually quite dangerous for them, especially in the deep caves and around old aging infrastructure. So this would be able to go in there and replace divers in those dangerous situations.
Has anyone ever used the Cuttlefish technology before? Is that something that's kind of known out there as being, a good way of maneuvering through kind of spaces as opposed to propellers?
other AUVs have used inspiration from animals before. We're not the first, but a lot of underwater vehicles use inspiration from manta rays and traditional fish, not so much the cuttlefish like we have. So we've decided to go with the cuttlefish because it's differentiates us from all the other products out there and gives us the maneuverability that we're looking for.
Yeah, because its range of movement is huge, right, in comparison in terms of going forwards, up, down, backwards and forwards, just from a standing stop. It's quite an impressive creature in itself, right?
And that's where it sets apart from your submarine-style AUVs as well. So imagine trying to have something like a submarine with a rudder, trying to get through a tight cave system, going straight up and straight down. Just can't do it. So they're good in the open ocean, but there really isn't anything other than divers at the moment which can get in those really complex areas.
And it's a very versatile product, right? So when we spoke before, we kind of went through the different applications that your product could be used for, and there's quite a range of potentials for it, right?
We've identified a number of different areas. So we looked first at research, so around coral reefs, that kind of thing. We've also designed it in a way so you can mount any payload to it, whether it's sensors or cameras, which can collect all the information that like the marine scientists and the research side of things they're trying to get. The other side of it is a commercial side. So we've spoken to a big energy provider in Australia who have the hydroelectric dams. They've got big water tunnels that they need inspecting. So we could mount a camera onto our device, send that down there, can do the inspection for them.
Yeah, so really what we've created is, instead of making an underwater vehicle, which is great for just a specific application, we've created a platform which can be used for a range of different applications.
It's also recreational, so we can mount the camera, go diving, you have something following you.
Of course.
Yeah.
And there's something so interesting about like kind of those different applications and thinking, especially around, you were starting to say about the safety factor of like, as we're starting to kind of go even deeper into more kind of dangerous places, whether that's equipment, let's say in like the oil industry, that we're moving much more towards like kind of a safety conscious, do we need humans in there at all?
Yeah, and it's safety not just for the humans, but also the environment that you're surrounding. So those really sensitive ecosystems where you've got people in there, it really disturbs the area, and especially with vehicles with a propeller, trying to study fish, and with a big propeller, it's just useless. So that's when the low intrusiveness really comes into it.
So it's kind of the sort of ideal invention for the Internet of Things generation, right? I mean, it's like a Swiss Army knife for under the water in terms of being able to do a multitude of different tasks, right? Are there any sort of very adventurous tasks that you want to aim the product towards? If finance wasn't an option, you'd say this is what we're going to do.
Well, there is there's a lot of different applications. We've talked about the research, being able to go down and get live data about ocean conditions to track climate change. You've also got defence, being able to use it to carry payloads and surveillance. We're also looking very, very long term in the future. They've got the icy moons surrounding Jupiter. They're looking for vehicles that can swim under the ice to collect data there. This is a potential candidate for that.
So we're thinking Europa
right,
with the big ice crust, right?
Yeah.
Yes.
Wow.
Interesting.
What would make this, your invention such a good fit for an environment like that?
If it survived Sweden, it will survive Bruce Lakes.
Have you tested it in extreme cold kind of water conditions?
We haven't been able to get there yet, but I think our definition of cold in Australia is much different. Than
I reckon the flight was pretty cold. And it seems to...
It survived the minus 65 degrees on the flight over the way.
So you brought it all the way from Australia to Sweden now, and as we mentioned when you guys brought it in, if I worked in an airport, I might be slightly worried by this.
There's a lot of wires.
Yeah, it's a big metal cylinder full of wires, and I think at the moment we're using shotgun pellets to ballast the weight. So, yeah.
And you guys, you did actually get a letter from the university saying it wasn't.
Yes,
a bomb.
we've branded out of the suitcase that it's in, just to make it look as official but as innocent as possible.
And you didn't have any problems coming?
No.
You managed to get through?
We were all good. There is another funny story about that as well. As we were taking it to be anodized into the black colour, we were pulled over for a random breath test, as what happens in Australia. And we pull up and we're in the university car, and the guy comes over, breath tests us, and then goes, "What is that?"
This big metal
thing that I'm holding in my hands, and I was like, "It's a university project." He's like, "Well, it looks like a bomb." So, and then so
I feel
we're a little bit of explaining to do there.
We were obviously clueless, so he let us go.
Yeah,
You had that look on your face.
Once we started explaining the benefits and all the data we're going to gather.
Once he realised that we were just nerds.
And so I'm super excited by that. The thought of being able to drop this invention into Europa and to be able to swim under that ice crust and be probably one of the first elements that could go under there to discover what could possibly be there. That is the big ambition.
Yeah.
The ultimate goal.
The ultimate goal.
The ultimate, yes.
What steps have you taken towards this goal? Or is that still just sort of the big idea that you want to achieve?
Yeah, it's a long shot at the minute, but it's all of the technology and all of the design that we've put into it. It is feasible. We could do it one day. It kind of lends itself with the autonomy and the remote communications kind of thing. You could literally put it anywhere in the solar system, I guess, and still communicate and still control it.
We've created the platform. It's really up to the creativity and the ambition of our customers to be able to also extend and be able to realise its full potential.
I love that. And is this, to kind of just go back a little bit, since, all of you are kind of centered in a type of engineering, a little bit of a variant. Is this the type of projects that you dreamed of kind of doing, or were you more kind of thinking on like product development side, and, I'd really love to design a snowboard?
I began as an aerospace engineer, so I thought I'd be designing vehicles that are flying, not in the water. So it's completely opposite from where I started. But it's been really awesome, and it's pretty much the same thing. It's just a different fluid. There's water instead of air.
I think, it's definitely been the dream to design something this cool. Like 5 years of university has resulted in something that we're proud of, and this is what we got into engineering to do: design something cool, have something working.
And change the world, right? I mean, this is like a big invention that has many applications, right? And as you say, I love the thought of you guys considering this a platform, which is a really great approach, right? It's not just a product, this is a platform. And with the Internet of Things approach, it's like, basically, you could give out little nodes. You can buy the base and then create the node yourself.
The starter pack.
Yeah, the starter pack, right?
Like a swarm network of these just swimming around everywhere.
Yeah.
That would be so amazing.
Wouldn't it be great?
Terrifying. Terrifying. Can you imagine you're just snorkeling a bit and you just see like a stingray pattern of these coming at you?
I'd love that. I'm kind of down with that. That's kind of like a sci-fi thing in my head.
Every time I go surfing now, I just imagine them under my feet.
Yeah.
Scaring away the sharks for me.
Oh, that'd be fun.
This is another application, right? So scaring away a shark. I mean, you kind of mentioned it in jest, but there is what you were saying earlier about using the product to search and create a data map, right? That in itself, I mean, you could be able to map shark movements and things like that. The limitations for the amount of data that you could pull is it's huge.
Yeah, so we could put any sensor, any camera, anything on it. We're limited by, I guess, how big the hard drive you put in it is. So we could collect any kind of information, or even not even that, because it's all sent to the cloud.
I was going to say with the cloud.
With the cloud, it's
And at the moment,
limitless.
At the moment, we have created a prototype. It's a certain size, but this technology is easily scalable up and scalable down. So if you want to be collecting samples of rocks and dirt and something like that, which are huge, then you'd be able to easily just scale it up, still have that same maneuverability. Same if you want to get really stealthy, have something which is just for surveillance with a small camera on it, being able to potentially in defense applications, be able to go behind enemy lines without being detected, or getting to those really complex little reef systems to study certain animals. It can be scaled up or scaled down, and that's the beauty of having a modular system.
Well, because I was also, the first thing that sort of came to my mind when we started talking about that of tracking is obviously migration patterns and things like, kind of tracking animals over generations to see how migration patterns change and, how climate change is affecting them, things of that nature. And what you just said, Josh, really kind of sparked that interest in me of like, is now the perfect time? I mean, obviously for autonomous vehicles, now is the perfect time because we have the networks to support them. But specifically around the cloud computing, is this kind of one of those things that's the perfect time for an invention like this because you really don't have a limit on sending data?
Definitely. It's kind of scary when you look back at even just the last 5 years, how far we've come in terms of cloud computing and how cheap it is now. Yeah, we've hit the mark where that technology's just exploded.
That must be really exciting for people in your position as well. For like students to kind of be at this like point, and even as young professionals to be at this point where you're like, I know I can access this technology because it's not just for the elite. It's been a little bit more democratized, and there's so much to do with it. Does that kind of just like send off all these like light bulbs in your head to be like, oh yeah, we could do this. We could change it that way.
Definitely. And there's the support of these larger companies like Ericsson. In Australia, we have Telstra that are able to support those upcoming IoT projects. And I think that's something hopefully we'll be able to look into developing our vehicle with maybe.
Because that's one of the reasons why you guys are here, just for anyone who's listening. So you guys are here as part of the Ericsson Innovation Awards, right? Which is in a couple of days. And there are 4 finalists. Your team being one of them. How would winning the award itself, how would that help? How would that change what you guys are doing at the moment?
I think we'd like to use the money to fund further research into, say, the autonomy part, which is something that we lack in skill sets. So if we can get funding for that to develop the autonomy, and then also develop the power generation aspects of our project. So that's the main reason we want funding.
Yeah, as much as we all think we're the best at everything, it would be great to bring in some experts, especially around the autonomy side of things. And
we are but humble mechanical engineers.
That's probably the first time you've ever said that, isn't it? I'm just saying, of all the mechanical engineers I know, that's not a common phrase.
Josh also has the buy some beers for people back home.
Yes, I did make a promise to the people that I work with that if we won, then they'd all be getting beers.
How many people is that? Are we talking a lot of beers?
We're talking a lot of beers.
A lot of beers. So please, we really need that money for the beers.
And where do you work, Josh? What kind of like support did you realize was kind of, in a good way, necessary from the outside to be like, oh, this is kind of where we want to be pushing this? Or...
Yeah, so I'm in the mining industry, but they were super supportive with this project, and it's a once-in-a-lifetime kind of opportunity, so they really got behind me. All my mates there have been voting for us in the People's Choice kind of thing, and yeah, it's been really good to have all that support.
I think my grandma gave me the most support out of anyone. And dead set, she is more excited on me coming to this trip than I was.
Yeah.
She's been sharing it all over Facebook. All of her friends have been getting around it.
Oh man,
it's been amazing.
Never doubt that older demographic who like to vote on Facebook. You never doubt the power of that group.
Yeah, I mean they like to vote in real life, right? And they always turn out, so it's always good to get them on side.
That's amazing.
How about you guys?
My mum's been sharing it everywhere,
Yeah.
so I've been getting random congratulations from relatives I don't even
Yeah.
know from India. So it's been good.
No, definitely, it's been good. I do lifeguarding in Australia, so every time we're training and someone finds a cuttlefish bone, they throw it at me. It's good fun. But yeah, we've definitely had a lot of support from our friends back in Adelaide, and also everyone that we're studying with at university.
Shout out to our supervisor, David Harvey.
Yes,
Woo.
he's been a great support for us developing this project, and I don't know if we could have got here without his support and enthusiasm.
And we talked about this a little bit earlier, but I'll kind of pose the question to you all again: is that what is your wildest dream for this project, even bigger than the moons of Jupiter?
We'll buy Facebook.
I don't know if you want that responsibility, man.
And let's
It might be going
pause the
cheap in a couple
recording
of
and
years.
we'll start again. Now what?
We just want to see how far we can go with this idea, to see how much interest we can get. So we did show this off at an exhibition at university, and there was a lot of interest from government, defence.
Yeah.
and
Defence.
commercial.
I could see
Defence
really
love it,
jumping
yeah.
on this.
We're trying to want to go more research, but
Yeah.
We just want to see the extent that this technology can be used in applications. Applications that we haven't even thought of. We've had people coming up to us saying, hey, that would be great for this and this.
We're taking it one step at a time. We're not looking too far in the future.
I love that though, because I think the most amazing thing about what you've created here is that there are so many opportunities that it can go so many directions, and you probably won't find that out, like you said, until you just start really pushing those limits, which is really exciting for you all and for us.
And I hope to see you guys testing it out in the Ericsson pool out the front. I think it'll be really great.
It might be ice skating on it today. It's pretty cold.
Well, guys, best of luck. I hope the awards goes well, and thank you so much for coming to join us on the Genuine X podcast. It's been really great to meet you, and we'll make sure we keep an eye out because it's a really exciting invention. So thank you for sharing it with us.
Thank you for having us.
Thank you for your time.
Thank you, and congratulations to this year's winning team, Adelaide Bio-AUV. We look forward to seeing what the future holds for you guys. This platform truly does have limitless potential, and I hope you guys manage to get the beers that you promised. Once again, congratulations. You can find out more about the Ericsson Innovation Awards and all the other finalist teams at ericsson.com, where you can also find details on how to apply for next year's Ericsson Innovation Awards. All links can be found in the description below. Thank you for listening to the Genuine X podcast, and don't forget to like and subscribe.